Hi, today we are going to talk about the punctual operations. And we will start by giving you a description of the algorithms that can be used for the transformation of images. Then we have the algebraic operations, like the addition, that is used to make averages, which help us to eliminate random noise. The subtraction, that this type of operation has mainly two applications: to standardize the lighting of an image and highlight objects. To standardize the lighting, first you need to make a blurring of the image, and this way we can get the background. The multiplication, that is the operation that can be used to overlay textures or masking regions. This last one is only used to see the region of interest in the image. And then the division, that is used to remove some random artifacts. In this operation, we found a big problem, that the image gets undetermined. Then the Boolean operations. We have the intersection, the union, the complement, and there is no other type of segmentation by planes of bits, where the more significant plane is information and the least significant plane is noise. For the geometric operations, we have the scaling or the zoom. That there are two ways to do the scaling: as a replication, that is when the picture looks pixelated, and by an interpolation, that is when the picture looks smoother. In the same way, a small image can be converted to large one by two methods: and a single pixel, selection, and interpolation. The translation, that can be used in quantum mechanics, and this operator shifts particles and fields by a certain amount in certain direction. The reflection, this means doing a mapping from an Euclidean space to itself, that is an isometry with an hyperplane as a set of fixed points. The rotation, that is used by a rotation matrix, which will perform a rotation in the Euclidean space, or can mean the representation of an arbitrary rotation of the axis about the origin. And the deformation. The polar logarithmic transformation can make the shift from Cartesian coordinates to logarithmic coordinates. This type of processing is performed because the retina of the eye has a similar transformation, and it's used for pattern recognition, the registration, that are a series of operations such as rotation, translation, among other ones, that are applied to an X image, so as result we get a Y image similar to the previous one. And the object detection. Then the convolution-based operations. This type of operations requires a two-dimensional mask. The size of the mask depends on the size of the image. It can be used to soften an image, border detection, and correlate images to locate features and registration points. Depending on the mask used is the result obtained. Normally, soften an image is used to reduce the noise. The masks used in this operation are always odd, like we can see here, 2W plus 1, where W is the diameter of the object that we want to delete. The softened masks are used to lose the contrast. There are many kinds of these masks. The Gaussian mask, that in the center of the mask has a very large number. The average mask, that is used to remove borders. The medium mask, that the value that is assigned to the mask is the value of the average. This mask leaves the borders and the mask of maxima. For the borders detection, we have the unsharp mask. This mask softs the image and then it is removed only to leave the borders. Then the Robert mask, where there are regions of constant image intensity where the mask results are zero. The Prewitt mask, that it has some directionality, and the Sobel mask, although it detects borders, it can soft the image too. And the operator Kirch mask. This mask is used to found diagonal borders. All the masks mentioned previously use the first derivative, but we can also use the second derivative to find points of inflection. And the second derivative, that is used to find areas of rapid change or inflection points. Thank you very much. That's all.